All right, in this video, we're going to do a run through of possible combinations of velocity and acceleration vectors. My students would have a handout that looks like this, but I will put a link to it in the description of the video if you'd like it. So the way we're going to read this chart is we have possible combinations of velocity and acceleration. And depending on where we are on that chart, we're going to either have positive velocity, zero velocity, or negative velocity. And then on the other side of the chart, we've got either positive acceleration, zero acceleration, or negative acceleration. We're going to use green vectors to represent velocity vectors and red vectors to represent acceleration vectors. Keep in mind the vector, positive and negative, is telling you direction. By convention, to the right is positive and to the left is negative. So we're going to start in the upper right corner where we have positive velocity and positive acceleration. We're going to show what that looks like vector-wise and then also describe what motion that would represent. So we'll start with a green arrow pointing to the right. That's our positive velocity. And then a red vector also pointing to the right. That would be our positive acceleration. So this object would be moving to the right and also accelerating to the right. So that means it'd be moving to the right and speeding up. Okay. So let's move over to the middle here. We have zero velocity. So I'll just write v equals 0, no vector. And we do have still a positive acceleration. So if this were our object, zero velocity means it's not moving. If it's going to accelerate to the right, that means it's going to speed up from rest to the right, okay? This would just be one instant in time. The very next instant in time, there would be a tiny velocity vector there, okay? So I'll describe it as speeding up to the right or to the right from rest. And again, that only captures one moment in time. The next very instant in time, you would have some velocity. Okay, on the left here, we've still got positive acceleration, but negative velocity. So the negative velocity entails that the object is moving to the left. If the acceleration vector opposes it, that means that the velocity is decreasing. This object would be slowing down while moving to the left. And that's a key aspect of opposition in these vectors. Whenever you have the vectors opposing one another, you're going to have slowing down, okay? So we do need to get in the habit of realizing that just to say there's a positive acceleration doesn't necessarily mean speeding up. In this case, because the velocity is negative and the acceleration is positive, the object is definitely slowing down. Okay, let's go back to the right-hand side here with positive velocity, zero acceleration for this entire row. Zero acceleration just means we're going to have constant velocity. We're going to have steady motion, okay? So we would just have constant speed to the right. No acceleration. Right in the middle, zero velocity, zero acceleration. Means no motion, right? This object is at rest. And then still zero acceleration, but negative velocity now. A leftward pointing velocity vector. Acceleration 0. Again, that's going to be constant speed, so constant speed to the left in this case. And in our final row, we're going to have negative acceleration. Let's go back over to the right. Positive velocity to the right. Negative acceleration to the left. And so if the object is moving this way but accelerating this way, that means it's slowing down while moving to the right. Okay, again, vectors in opposition means slowing down. Zero velocity here in the middle. Negative acceleration means to the left. And so again, this object is at rest, but it's going to accelerate to the left. So the very next instant, we would see a very tiny velocity vector, which would get larger and larger if we continued with that acceleration. So let's say speeding up to the left from rest. And then finally, we've got negative velocity to the left, negative acceleration to the left. So this object's going to be moving to the left and accelerating to the left. That means it's going to be speeding up. So moving to the left and speeding up. So again, we can't assume that a negative acceleration always means slowing down. It's directional. So we can have a negative acceleration paired with a negative velocity, and that object would be speeding up. So this is all the possible combinations of velocity and acceleration if we're looking at one-dimensional motion. So this is a good way to just summarize all the things that you might see in the lab if you're studying carts on ramps or things like that, where you're going to see acceleration. So hopefully that's helpful. If you have any questions, please put them in the comments below. And as always, thank you for watching.